So, I do think it's possible that at the moment, there's one civilization in the Milky Way. Holy wow, this is amazing. We are going to be learning so much in the coming decades. Located 7 trillion miles away from Earth is an unprecedented discovery made by the James Webb Telescope, city lights in space. This remarkable finding has ignited a strong wave of curiosity about the possibility of extraterrestrial life. The telescope focused on Proxima Centauri b, the closest exoplanet to Earth, showing unusual bright lights emanating from it. What could be responsible for these city lights on Proxima Centauri b? Could this signify the presence of life beyond our planet? Come with us as we delve into how the James Webb Telescope detected these extraordinary objects in space. For years now, scientists and humans in general have carried out research to get a glimpse of life beyond our solar system. Any evidence perceived to back up this fantasy about space has been gladly welcomed over time. Recently, the scientific community got the shock of their lives when solid evidence of life forms existing in space was observed by the James Webb Space Telescope. While scouting outer space and relaying vital information back to Earth, the James Webb Space Telescope noticed strange city lights shining from the exoplanet Proxima Centauri b. Just as its name implied, the city lights looked like they lit up a distant city. The possibility of an alien city existing on the star has left scientists reeling in amazement. Every one of them is baffled because it seems like this is the existence they've all been waiting for. If this turns out to be true, as everyone thinks it is, it means that there are intelligent life forms organizing civilizations foreign to what humans know in outer space, and we're only just discovering it. Peering into the city lights that are located 7 trillion miles from the Earth, NASA engineers can't help but wonder how long these lights have shone in space, waiting for humans to grow the required technology to detect them. David Kipping, an astronomer from Columbia University, describes the Proxima b exoplanet, where the city lights were found, as tricky. He said so because this star system nearest to us has varied heating patterns that aren't similar to other planets. The usual rocky planets are known to take in sunlight and emit infrared radiation. However, it's not so for this exoplanet, as its infrared nature is quite different from that of its host star, named Proxima Centauri. This makes for a good observation by the James Webb Space Telescope, JWST, and the telescope came in handy as the right tool for the job. The JWST is able to easily detect infrared wavelengths. The characteristic heat signature of Proxima b will play a huge role in discovering the universal secrets of its atmosphere. This will be as a result of the latest technological advances in infrared imaging capabilities possessed by the JWST. Scientists plan on utilizing the telescope to reveal the mysteries surrounding this planet's atmospheric conditions. They also aim to use the Webb telescope to check the possibilities of residing on this exoplanet. The James Webb Telescope has an infrared sensitivity that's required to explore what happens at Proxima Centauri b's nighttime, picking up the faintest rays of light in the cosmic darkness. It's usually a struggle for space telescopes, but not for the JWST, as it can pick out even the tiniest rays of light from space. It's the perfect instrument to verify if the rumors of city lights on Proxima b's night side are true or false. Every artificial illumination in the cosmos can be sensed by the telescope as long as it falls within a frequency band that's 1,000 times narrower than starlight. How does Proxima Centauri b compare to planet Earth? Proxima b has an interesting relationship between its stellar features and surface interactions. The day side of the exoplanet contains many solar panels that harness the bubbling radiant energy possessed by the star. Its spectral edge also reflects incoming light rays. At the same time, when Proxima b completes its orbit around its host star, Proxima Centauri, it experiences day and night periods just like on Earth, with the daytime getting high on solar heat and the evening experiencing coolness. The planet is known to have temperature fluctuations determined by its composition. For example, if there's no atmosphere on Proxima b, the difference between its day and night periods will be wide and far between. If there's no moderating influence of atmospheric gases and oceans, the temperature of the day side will be so hot like a black body, and the night side will horribly drop into cold darkness. The degree of temperature variation is a good subject for astronomers to unravel for a deeper understanding of Proxima's atmospheric composition. Having an unrivaled infrared imaging capability, the JWST can efficiently examine the planet's thermal emissions to provide insightful data about its atmospheric properties. Interestingly, the orbit of the James Webb Telescope around the Earth aligns with Proxima b's orbital period, allowing for complete observations of its day and night periods within 11.2 Earth days. If it indeed has an atmosphere, the next step will be to assess its atmospheric chemistry to determine if it can accommodate life. Some good pointers in determining if there's life include the presence of gases like oxygen, water vapor, and methane. If these elements can be found on the planet, it means that it supports habitable conditions. The process of successfully determining this requires scientists to be meticulous as they capture and examine light rays that move through the planet's atmosphere. This is an incredibly challenging task to undertake, even if the JWST possesses great capabilities for characterizing planetary atmospheres. However, it has a different major objective. The telescope is designed to analyze variations in water vapor, carbon dioxide, and methane concentration. When it comes to identifying bonded oxygen, a vital indicator of life, the JWST is limited in this area. Even so, the telescope still has valid reasons to search for other elements on the planet. One such reason is ozone, which gives away an accurate level of vitality in the atmosphere. It's also worth mentioning that the James Webb Space Telescope doesn't have absolute capabilities and can only peer at a few of the closest habitable worlds to Earth, carrying out thorough atmospheric investigations. Astronomers are now tilting toward ground-based observatories like the Extremely Large Telescope, ELT, which is scheduled to start operating in 2028. Positioned to gaze deeper into the atmospheric structure of faraway exoplanets, it will produce data offering comprehensive and vivid insight into their level of habitability. NASA scientists and everyone else are eagerly waiting for the deployment of future space telescopes like this one. Until then, the James Webb Space Telescope will continue to be a vital tool in our quest to uncover the mysteries of distant exoplanets, even with its current limitations. The James Webb Telescope has the potential to offer deep insights that will revolutionize our understanding of exoplanetary exploration now and in the future. Scientists have an objective for future space telescopes: to reduce the amount of bright light coming from a planet's host star, so astronomers can clearly see the lights reflected from a planet itself. They plan to do this by using internal masks or gigantic external satellites shaped like an umbrella, similar to using your hand to block out rays of the sun to enable clearer vision of an object. In the bid to reduce the fierce brightness from the host star, future telescopes will be better positioned to study faint reflections of light coming from distant exoplanets, allowing for a clearer analysis of their atmosphere and likelihood of supporting life. This comes with challenges, however, as scientists will have to differentiate between gases generated by life and those produced by geological processes, such as volcanic activity. Astronomers aren't relenting in their quest to understand exoplanets' characteristics, so they can better discover signs of life and distinguish them from false positives. The Webb telescope provides a preview of scientific advancements from the study of exoplanets, offering a sneak peek into the amazing discoveries yet to come. As we stretch our understanding and exploration of the cosmos further, we are better positioned to understand the intricate workings of the universe and our roles in it. After looking through all the planets in space, scientists have yet to find any that host life, despite decades of searching. The quest for forms of life on other planets continues. Are we alone in the universe? For millions of years, humans have always wondered whether they are the only ones living in the universe. This old longing still exists today. Scientists continue using the James Webb Telescope in outer space to try spotting alien civilizations hidden among us, while studying planetary bodies for signs of life. At the same time, the narrative that aliens may be out there in the stars, waiting for humans to find them, remains a popular one. To help provide an answer to this question, two American astronomers, Jill Tarter and Thomas Pearson, started a project called the Search for Extraterrestrial Intelligence, SETI, in 1984. Their non-profit venture aims to sift through cosmic signals to pick up radio signals from space. Radio signals can travel long distances without being scattered or absorbed like other types of radiation, making them ideal for detection by the 42 radio telescopes of the Allen Telescope Array in California's Cascade Mountains. Though the SETI Institute has diligently observed space for signs of alien-generated radio signals for over 30 years, none have been detected. Yet, Jill Tarter remains enthusiastic, hoping for positive results as they aim to use 21st-century tools to accelerate the search. In her words, "I wish that you would empower Earthlings everywhere to become active participants in the ultimate search for cosmic company." All of this continued until recent reports from NASA implied that the James Webb Space Telescope had spotted city lights from a planet close to Earth. The JWST is humanity's giant trump card in grasping the universe. It is currently the most advanced instrument designed to unearth the mysteries of the universe. The telescope, floating about 1 million miles from Earth, sends back accurate details about the earliest periods of the universe. It's designed to capture elusive facts about space and provide clarity on the formation of galaxies, planets, and stars. Astronomers are making full use of the JWST's cutting-edge technologies, such as its stellar camera feature and filters, to spot and analyze the delicate colors that surround celestial objects. Researchers are comfortable using the telescope to collect data about the physical properties and chemical compositions of distant celestial bodies. This is done by isolating specific wavelengths of light far beyond mere observation. The Webb telescope continuously gazes at the atmospheres of exoplanets for faint traces of life, no matter how small. It has unparalleled power to analyze the fabric of time and space and has revealed some of the most intriguing findings ever. One such discovery was more mass in giant galaxies than previously believed, casting doubt on earlier understandings of the universe's layout. Humanity has since embarked on exploring the farthest reaches of the cosmos, with the JWST serving as a key tool in this quest. Through the telescope, new information on isolated worlds will be documented, and more astrophysical data will become available to solve the mysteries of these planets. 20 years ago, the cosmic realm outside our solar system was largely unexplored, but since that time, astronomers have identified over 4,000 exoplanets. Exoplanets that orbit distant stars demonstrate the remarkable extent of human ingenuity, but NASA considers these discoveries to be just scratching the surface of the celestial iceberg. Scientists believe that in reality, there are trillions of undiscovered exoplanets scattered throughout the cosmos. Despite the challenges, scientists have not given up their decades-long quest to explore space in hopes of discovering alien habitats in uncharted regions. They have encountered glimmers of hope along this journey. One such discovery is the vegetation red edge, VRE, first detected by the Galileo spacecraft during its journey to Jupiter. This biosignature, indicative of extraterrestrial vegetation, was the first of its kind to suggest the presence of life beyond Earth. The VRE operates by analyzing how vegetation reflects light, and the James Webb Space Telescope, JWST, is expected to use this technique to unravel the mysteries of extraterrestrial environments. By carefully mapping the orbital parameters of potentially habitable planets in the habitable zones of their stars, the VRE could provide crucial evidence in the search for intelligent life forms outside Earth. When sunlight passes through atmospheric layers, different wavelengths are absorbed by the atoms and molecules present, forming a unique spectral pattern that can be identified through spectroscopic analysis. The JWST can detect light from stars as it passes through a planet's atmosphere, offering insights into the atmospheric composition of planets similar to Earth. Such planets, with atmospheres rich in carbon dioxide, nitrogen, and oxygen, might harbor life, though the absence of certain compounds may suggest alternative forms of life or even technological civilizations. For instance, artificial molecules like chlorofluorocarbons, CFCs, used on Earth for refrigeration and other industrial purposes, could serve as proof of extraterrestrial civilizations if detected on exoplanets. The JWST's ability to detect such molecules could provide undeniable evidence of extraterrestrial activity. The search for life beyond Earth is vast and complex, transcending earthly biology. Life on other planets could exist in extreme forms, much like extremophiles on Earth, organisms that thrive in conditions once considered inhospitable. These organisms can survive in temperatures up to 250 degrees Fahrenheit and in highly acidic environments, demonstrating the resilience of life. This discovery broadens the scope of the search for extraterrestrial life, which must be equally extensive, especially when studying planets that resemble Earth and orbit stars similar to our Sun.